In 2021, a virus began moving across continents. Not through cities, not through crowds, through the sky. Carried silently inside migrating birds, H5N1 was spreading to every corner of the world. By 2024, it had done something no one anticipated. It found its way into American dairy cows, replicating not through the lungs, but through an entirely different organ. H5N1 carries a surface protein called hemagglutinin, the key it uses to lock onto host cells and force entry. In birds, it binds to receptors throughout the respiratory tract and replicates explosively, spreading through the bloodstream to every organ within days. Wild waterfowl carry it silently, but domestic poultry, an entire flock, can be wiped out in 48 hours. When dairy cows started getting sick in 2024, no one expected what scientists found. H5N1 was not in the lungs, it was in the udders. The receptors H5N1 uses to enter cells are concentrated in high densities inside bovine mammary tissue. The virus had been replicating there silently for weeks. It was spreading through milking equipment, carrying virus-laden milk from cow to cow. Raw milk from infected cattle contained live H5N1 in alarming concentrations. Pasteurization destroys it. Raw milk does not. So why isn't H5N1 spreading between humans? One receptor. Human upper airways carry alpha-2 to 6 receptors. H5N1 is adapted to alpha-2 to 3, an orientation it cannot efficiently grip. To infect a human, H5N1 must bypass the upper airway and reach deep into the lung. But when it gets there, the consequences are severe. Since 1997, fewer than 900 people have been infected worldwide. More than half have died. The virus destroys lung tissue, then triggers a cytokine storm. The immune system overreacts so aggressively, it begins destroying healthy tissue alongside infected cells. One of the body's greatest strengths, becoming its deadliest weakness. For H5N1 to become pandemic, it needs two things: a mutation to bind human upper airway receptors, and the ability to spread between people. The most alarming pathway is reassortment. When H5N1 and a human flu virus infect the same cell, their genetic segments can mix, producing a hybrid carrying H5N1 lethality with human transmissibility. This mechanism contributed to the 2009 H1N1 pandemic. The world is not watching passively. Candidate H5N1 vaccines exist. mRNA technology can produce an adapted vaccine within weeks. Antivirals like oseltamivir reduce severity when given early. Surveillance networks track every mutation in real time. The 1918 pandemic killed 50 million in a world without any of these tools. That world no longer exists. H5N1 remains a virus of birds and cattle. But every infection in a mammalian host is an opportunity for mutation. Understanding this biology is the early warning system that has a chance of catching the next pandemic before it catches us. That's it for today's video. If you enjoyed it, it would mean a lot if you could leave a like and subscribe to the channel. Thanks for watching, and see you in the next one.